Okay, this is the last set of notes for term 1 of secondary math 1, and this is kind of compiling everything we've learned about. We're dealing with solving, we're talking about absolute value, and we're talking about inequalities, so let's go. All right, so memory lane, few reminders. Remember what absolute value means? It means the distance from 0. So on a number line, here's 0. If I want to find the absolute value of 2, I'm looking for this distance right here. The distance between 0 and 2 is 2. The distance between 0 and negative 2 is also 2. Now, absolute value of a number is always going to be not negative. It'll always be positive or it'll be 0. Okay, now that's what the absolute value of negative 2 equals, and that's what the absolute value of 2 equals. Now the next question says, you've got the negative absolute value of 2. So that means find the absolute value of 2, but then make it negative. So the absolute value of 2 is 2, but when I apply that negative sign, I get negative 2. And then similarly, this is like negative absolute value of negative 2. The absolute value of negative 2 is 2. But if I have the negative on the outside, my final result would be negative 2. Okay, now remember that the absolute value of x means the distance between x and 0. So if the absolute value of x equals 2, that means that the distance between x and 0 is 2. So if we had the inequality, the absolute value of x is less than 2, that means the distance between x and 0 is less than 2. Could be 2, could be 1 or 0, but it's less than 2. That distance is less than 2 based on that inequality. So to graph this, what you would do is circle 2 and circle negative 2. The distance between x and 0, see like on the left side, that distance would be up to 2. And on the right side, that distance would also be up with 2. So if x is any number between negative 2 and positive 2, then the absolute value of x would be less than 2. X could be any of these numbers to satisfy this inequality. Remember, between involves double less thans. If we have the absolute value, or if we have the inequality, the absolute value of x is greater than 2, what that means is the distance between x and 0 is greater than 2. So greater than 2 would mean it's on the outside. Any of these x values, the absolute value of it would be more than 2. Like the absolute value of 5 is 5. That's more than 2. The absolute value of negative 3 is 3. That's more than 2. So to write the inequality, we would say x could be any x value less than negative 2. That's going to have an absolute value greater than 2. Or x could be any value greater than positive 2. All of those x values, the absolute value of it would be greater than 2. So when you are solving absolute value inequalities, if you have the absolute value of some stuff with x, it could be less than some number c only if that number right here is greater than 0. Because remember, the absolute value of a number has to be not negative. Sometimes the absolute value can be 0, but it can't be a negative number. So we would have when you're solving these, if it says that the absolute value is less than, it's going to follow this form. It's going to be like the inequality, I guess the value of x, the equation part, in between two less than symbols. Now, if it's greater than some value, that's going to be an or statement like this, where we have two separate inequalities. So part of what you're solving today is you're going to have to like take an absolute value inequality and then write your separate inequalities that you'll actually solve and then graph. So for example, if we have the absolute value of x plus 7 is less than or equal to 2, the absolute value has to be less than or equal to 2. So that means it's between. So like x, that means x plus 7 has to be between 2 and negative 2. Okay, so because this number right here was 2, I'll have positive 2 on the right and negative 2 on the left. And because it's less than, you'll have those two compound and inequalities with double less thans. And again, this number right here on the right, that 2, it has to be positive to be able to keep going. So now I solve it just like in the last lesson. I want to get rid of this plus 7 right here. So I'm going to subtract 7 because 7 minus 7 will add to 0, and that'll just leave me with x. But I got to keep it balanced, right? So subtract 7 from the left side and the right side as well. Negative 2 minus 7 is negative 9. 2 minus 7 is negative 5. And then I copy down my inequality symbols. So x is going to be between negative 9, circle it, fill it in because of the double or the or equal to, and negative 5. Also circle it, fill it in, and it's going to be this segment right here. Now on part B, it says the absolute value of x, or of 8x minus 11, is less than 0. Okay, now remember, this can't be smaller than 0. The absolute value of a number cannot be smaller than 0. So because it cannot be smaller than 0, our answer would be no solution. You've got to have, we can't have this right here. It can't be less than 0. The absolute value will either be 0 or it'll be a positive number, but it can't be less. Okay, next example, the absolute value of x is less than or equal to 3.5. Okay, it can be less than or equal to 3.5. That's a positive number, no big deal. So that means that x has to be between 3.5 and negative 3.5. And there's actually nothing to solve there. That's it. We're done. So graph it. Negative 3.5 will be right here. Positive 3.5 will be right here. And everything in between. Next problem. The absolute value of 2w minus 1 is less than 11. It can be less than 11, no big deal. So when I write this, I'll have 2w minus 1 is less than 11. Or on the left side, we'll have negative 11, double less thans. So 2w minus 1, to solve that, I want to get rid of this minus 1. If I add 1, this, whoops. If I add 1, this will add to 0, and I'll be left with 2w. So add 1 on the left side and on the right side. Negative 11 plus 1 is negative 10. 11 plus 1 is 12. Copy down your inequalities. And now to get rid of that 2, if I divide by 2, this will reduce down to just 1w like I want. So we'll divide by 2 on the left side and the right side as well. Negative 10 divided by 2 is negative 5. 12 divided by 2 is 6. I divided by a positive number, so my inequalities will stay the same. So then I'll graph it, circle negative 5, Circle 6, leave them open because we don't want to include them, and then everything in between. Next problem, this is our first greater than, okay? C minus 1 has to be greater than or equal to 5. I don't really know why it copied it down twice. This doesn't need to be here. It's just the exact same thing. So what I'm going to do is I'm going to say C minus 1 could be greater than or equal to 5. That's true. Or C minus 1 could be less than or equal to negative 5. Okay? Because this is a 5, I'll also include negative 5 and less than or equal to it. Okay, that'll give me the outside. So the right side would be greater than or equal to 5. The left side will be less than or equal to negative 5. And then I solve these inequalities. So to get rid of the minus 1, I add 1 because negative 1 plus 1 will be 0. And this will leave me with just C. Add 1 on the right side of my inequality as well. 5 plus 1 is 6. Copy down the greater than or equal to. Okay, so C could be all values greater than or equal to 6. So circle the 6 and go to the right. Now for the other half of my inequality, this time when I add 1 to both sides, I'll get C is less than or equal to negative 5 plus 1 is negative 4. So circle negative 4, fill it in, and everything to the left. Next one, T minus M, the absolute value of that has to be greater than or equal to negative 2. Okay, think about this because I got that negative number, right? Absolute value of a number is always not negative, right? It's always 0 or bigger. So when is this going to be greater than or equal to negative 2? Well, because it's always going to be 0 or bigger, and that's bigger than negative 2. This value will always be greater than or equal to negative 2. So our answer is going to be all real numbers. Any value of M I put in there, the absolute value of 10 minus that number will always be greater than or equal to negative 2. So I'm actually going to use the whole number line as my answer. Could be all real numbers. Next example, x plus 3 has to be greater than 8. Okay, greater than 8, everything's normal, so let's go ahead and write my inequality. So that means that x plus 3 could be greater than 8, or x plus 3 could be less than negative 8. So as I solve, on the left side, I'll subtract 3 so that this adds to 0, and I'll be left with x is greater than 5. Circle the 5, everything to the right. X plus 3 is less than negative 8, so I'll subtract 3 from both sides so that this adds to 0, and I'm left with x is less than negative 11. So here would be negative 11. Circle it, and everything to the left. Okay, this one is a little bit interesting because it's not isolated. Normally it's absolute value and then inequality, but we've got some things going on with the absolute value. So the first thing you want to do, isolate first. So what I want to do first is get rid of this minus 7. If I add 7 to both sides, then this will add to 0. And I'll be left with just 3 times the absolute value of d plus 1. Negative 1 plus 7 is 6. Copy down my absolute value. Now to get rid of that 3, if I divide by 3, that'll reduce down to just 1 times the absolute value of d plus 1. So 6 divided by 3 is 2. I divided by a positive number, so keep your inequality the same. Now it's set up just like normal. So the absolute value of d plus 1, we want to find when it's greater than 2. So we're going to write our inequalities. So that means that d plus 1 could be greater than or equal to 2, or d plus 1 could be less than or equal to negative 2. So when I solve, if I subtract 1 from both sides, that will add to 0, and I'll get d is greater than or equal to positive 1. So circle the 1, fill it in, everything to the right. On the other side, if I subtract 1 from both sides, this will add to 0 still, and I'll get d is less than or equal to negative 3. So circle the negative 3, fill it in, everything to the left. Okay, so a few reminders. If you've got absolute value is less than a number, okay, then you're going to have it between the positive and negative version of that number. If you've got absolute value of a number is greater than a positive number, that means that you'll have x is greater than 1 or x is less than negative 1. So see the difference? If you've got less than, you'll get a between statement. And if you've got greater than, you're going to get an or statement with two separate inequalities. Okay, and then remember, this number right here cannot be negative. Okay, if it's negative, then you've really got to think about it. Sometimes it's negative like this example, and you get all real numbers if it had to be greater than. Other times, it's no solution, like this example. If it's less than 0, that means it has to be negative. It can't be negative, so no solution. Okay, there you go. You should be all set to do your practice.